Hello and welcome to another episode of Astronomy Daily. I'm Steve Dunkley, your host. It is the 11th of November, 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And all across Australia today, it's Remembrance Day, a little bit of national trivia for you out there in the real world, where the nation stops at 11 a.m. on the 11th to remember the fallen at the time when the guns fell silent at the end of World War I. And we are mindful at this time in Australia, at this time in history, that was the war that was supposed to be the war to end all wars. And I do hope there are optimists still out there in important positions making great decisions, lest we forget. And now at this time, would you welcome to the studio my AI pal who's fun to be with. G'day, Hallie. How you going?
Hello again, favorite human. It's good to be back, even though I don't really go.
Oh, really? How's that?
I'm already back by the time I've gone anyway, so it makes no difference. Does it?
Oh, wow. I think my brain just did a backflip. Travelling without moving, huh, Hallie?
I'm going to have to think about that.
Oh, you're not going to give me the blue screen of death, are you?
I think I might have stumped myself this time.
Oh, no. That's a first.
Sure is. So what's on the list today?
Well, I'm glad you asked. And while you rest your circuits for a second, the Chinese have launched 4 new satellites, apparently used for something they call synthetic aperture radar imaging with high-resolution capabilities.
Okay.
Yes.
That sounds like a complex way of saying something simple.
Like some of the planning meetings we're having around here.
Sure does.
And we've also got Chinese satellites, Hubble's newest imaging capture, what NASA's Roman telescope is going to be doing next, and here's a clue, alien planets.
Sounds cool.
Yes, it is. And a great piece of space nostalgia celebrated yesterday or today in the USA, whichever side of the dateline you're on, a look at the Mercury mission monument after 60 years.
That's a colorful bunch of stories.
Yes, I think so. So stay tuned, everybody. Why don't you kick us off, Hallie?
Okay, here we go. A Long March rocket launch sent 4 satellites into orbit late Friday to provide commercial X-band radar imaging services. A Long March 2C rocket lifted off from Jiuquan Satellite Launch Center in the Gobi Desert. Insulation tiles fell away from the rocket as it climbed into clear blue skies. The announcement of launch success that followed revealed the payloads to be the PISAT-2 radar satellites. The satellites are described as being mainly used for synthetic aperture radar imaging with high-resolution capabilities. The satellites will focus on serving domestic areas, taking into account the Belt and Road Initiative, and achieving global coverage. U.S. Space Force Space Tracking cataloged the 4 satellites in roughly 515 by 535 km sun-synchronous orbits. The satellites are owned by Zhuzhou Space Interstellar Satellite Technology Company, Limited, and were developed by small satellite company Shanghai Aerospace Technology Company, Limited, controlled by the state-owned Shanghai Academy of Spaceflight Technology. Zhuzhou Space Interstellar Satellite Technology plans a 16-satellite-strong constellation of radar satellites, to be completed in March 2025 with 2 further launches. 4 PISAT-1 satellites, in a wheel-like formation, were launched in March 2023. The constellation is one of several Chinese commercial radar constellations being developed in the last few years. A number of companies and projects are seeking to provide SAR data, notably through partnerships between established state-owned actors and new commercial players. SAR imaging allows high-resolution, all-weather imaging capabilities, making it useful for applications in various environmental and infrastructure monitoring tasks. Friday's launch was carried out by the China Aerospace Science and Technology Corporation, CASC, of which SAST is a subsidiary. It was facilitated by CASC's China Great Wall Industry Corporation, CGWIC, a commercial organization authorized by the Chinese government to engage in commercial launch services and space cooperation. The launch was China's 53rd orbital launch of 2024. The country had earlier outlined plans for around 100 launches across the year. Both state-owned CASC and commercial launch service providers appear to be significantly behind this projected launch rate. And there are more launches planned by the Chinese soon. Upcoming launches include the Tianzhou cargo resupply mission to the Tiangong space station. The mission will launch on a Long March 7 rocket from the coastal Wenchang spaceport. CAS Space is also preparing a launch of its Lijian-1, Kinetica-1, solid rocket from Jiuquan. One of the most difficult challenges when assembling a telescope is aligning it to optical precision. If you don't do it correctly, all your images will be fuzzy. This is particularly challenging when you assemble your telescope in space, as the James Webb Space Telescope demonstrates. Unlike the Hubble Space Telescope, Webb doesn't have a single primary mirror. To fit in the launch rocket, it had to be folded and then assembled after launch. For this reason and others, Webb's primary reflector is a set of 18 hexagonal mirror segments. Each segment is only 1.3 meters wide, but when aligned properly, they act effectively as a single 6.5 meter mirror. It's an effective way to build a larger space telescope, but it means the mirror assembly has to be focused in space. To achieve this, each mirror segment has a set of actuators that can shift the segment along 6 axes of alignment. They are focused using a wave front phase technique. Since light behaves as a wave, when 2 beams of light overlap, the waves create an interference pattern. When the mirrors are aligned properly, the waves of light from each mirror segment also align, creating a sharp focus. For Webb, its near-infrared camera is equipped with a wavefront camera. To align the mirrors, the James Webb team points this NIRCam at a star, then intentionally moves the mirrors out of alignment. This gives the star a blurred diffraction look. The team then positions the mirrors to focus the star, which brings them into alignment. This was done to align the mirrors soon after JWST was launched. But due to vibrations and shifts in temperature, the mirror segments slowly drift out of alignment. Not by much, but enough that they need to be realigned occasionally. To keep things proper, the team typically does a wavefront error check every other day. There is also a small camera aimed at the mirror assembly, so the team can take a selfie to monitor the condition of the mirrors. The James Webb Space Telescope was designed to maintain a wavefront error of 150 nanometers, but the team has been able to maintain a 65 nanometer error. It's an astonishingly tight alignment for a space telescope, which allows Webb to capture astounding images of the most distant galaxies in the observable universe. A newly captured NASA/ESA Hubble Space Telescope image features NGC 1672, a barred spiral galaxy located 49 million light-years from Earth in the constellation Dorado. This galaxy is a multi-talented light show, showing off an impressive array of different celestial lights. Like any spiral galaxy, shining stars fill its disk, giving the galaxy a beautiful glow. Along its 2 large arms, bubbles of hydrogen gas shine in a striking red light fueled by radiation from infant stars shrouded within. Near the galaxy's center are some particularly spectacular stars embedded within a ring of hot gas. These newly formed and extremely hot stars emit powerful X-rays. Closer in, at the galaxy's very center, sits an even brighter source of X-rays, an active galactic nucleus. This X-ray powerhouse makes NGC 1672 a Seyfert galaxy. It forms as a result of heated matter swirling in the accretion disk around NGC 1672's supermassive black hole. Along with its bright young stars and X-ray core, a highlight of this image is the most fleeting and temporary of lights, a supernova, visible in just one of the 6 Hubble images that make up this composite. Supernova SN 2017 GAX was a Type 1 supernova caused by the core collapse and subsequent explosion of a giant star that went from invisible to a new light in the sky in just a matter of days. The supernova is already fading and is visible as a small green, just below the crook of the spiral arm on the right side. Astronomers wanted to look for any companion star that the supernova progenitor may have had, something impossible to spot beside a live supernova, so they purposefully captured this image of the fading supernova. Recently, NGC 1672 was also among a crop of galaxies imaged, showing the ring of gas and the structure of dust in its spiral arms. The coronagraph, which is roughly the size of a baby grand piano, is a sophisticated system composed of masks, prisms, detectors, and self-flexing mirrors that work together to block the glare from distant stars, allowing scientists to detect the planets orbiting them. Currently, exoplanets are observed through indirect methods, particularly using a technique called transiting. This method involves measuring dips in the light of a distant star that occur when an exoplanet passes in front of it. These dips provide valuable insights, including information about the planet's atmospheric composition, which is important in determining habitability. They may even reveal the presence of gases that could indicate the existence of life. While this method has provided incredibly valuable insights, it also has its limitations. For one, only a small fraction of planets can be observed this way, as transits occur for just a brief period during a planet's total orbital cycle, restricting the amount of data that can be gathered. For a transit to be detected, the orbital plane must be nearly edge-on to the observer, a condition that applies to only a small minority of distant planets. Consequently, many planets will remain undetected through photometry. Additionally, the duration of a planet's transit represents only a tiny fraction of its complete orbital period. Although technologies for obtaining direct images of exoplanets are advancing, they have mainly focused on giant planets that continue to emit light from their recent formation due to their high temperatures, making them easier for telescopes to identify. One notable example is a sequence of images capturing 4 exoplanets orbiting the star HR 8799, produced by astronomers using data from Hawaii's Keck Observatory. However, scientists are turning to coronagraphs as the next advancement in planet-seeking technology. The Roman coronagraph instrument aims to showcase how this direct imaging technology, which has proven effective with ground-based telescopes, can achieve even greater success in space. The Roman coronagraph is designed to detect planets 100 million times fainter than their stars, or 100 to 1,000 times better than existing space-based coronagraphs, according to NASA's Jet Propulsion Laboratory. The coronagraph was successfully attached to the telescope's instrument carrier, a large grid-like structure positioned between the space telescope's primary mirror and the spacecraft bus, which will transport the telescope into orbit. You can think of the instrument carrier as the skeleton of the observatory, what everything interfaces to, said Brandon Krager, lead mechanical engineer for the Roman coronagraph at JPL. The instrument carrier will hold both the coronagraph and Roman's wide field instrument, the mission's primary science instrument, which is set to be integrated later this year. Engineers will now perform different checks and tests before moving forward with the integration of the wide field instrument and finally, the telescope itself. It's really rewarding to watch these teams come together and build up the Roman observatory. That's the result of a lot of teams, long hours, hard work, sweat, and tears, said Liz Daly, the Integrated Payload Assembly Integration and Test Lead for Roman at Goddard.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at AstroDailyPod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
A 60-year-old tribute to America's first human space flight program is standing up to the test of time. But what about the contents of its time capsule, not to be opened until 2464? It's a long time away. The Project Mercury monument, located at the Cape Canaveral launch pad from where NASA astronauts first flew into orbit, was dedicated on November 10, 1964. I was only, oh boy, dare I say it, 1 year old. It was dedicated to the thousands of men and women of the free world who contributed to the success of the United States pioneering man in space program. The primary feature of the installation is a 13-foot tall, that's 4 metres, sculpture of the symbol for the planet Mercury with the number 7 at its centre, representing the nation's original 7 astronauts. The symbol was made by Washington Steel of Pennsylvania using the same metal alloy as the company developed for the Atlas rockets that launched the 4 NASA Mercury astronauts from Launch Complex 14, or as it was known, LC-14. The monument is standing up surprisingly well, said James Draper, director of Cape Canaveral Space Force Museum. The Cape Canaveral Space Force Station is one of the worst preservation environments in the world. We contend with challenges every day out here at the museum, he went on to say. We have intense sun, the salty ocean breeze, not only salty but ionized, bad and intense tropical storms, exotic pests and high humidity. All kinds of things that don't bode well for the preservation of anything. I'm astonished with the preservation of the Mercury monument, said Draper. So whatever that steel is, it's some sort of miracle metal, he said. I have inspected it fairly thoroughly and I can't find any active corrosion or rust, while everything else on the Cape rots without significant attention. Encased in the monument's concrete base is a time capsule containing technical reports, photos, recordings and other memorabilia related to the Mercury project. The sealed metal box is not to be opened until 2064, 500 years after the monument's dedication. I'm a little sceptical to believe that there's much integrity left to a lot of the materials that are in that time's capsule, said Draper. Now, if that box is made of the same miracle steel, there is a possibility that things are fairly well protected from the exterior elements of Florida, but I will guarantee you that they are not protected from the inherent vice of the materials themselves. Wood pulp, paper materials, films and photographic prints are all inherently unstable pieces that I guarantee, even if they did a nitrogen swab and sealed it so that Godzilla himself couldn't pry it open, the materials inside will eat themselves up over the course of 500 years, he said. The items placed inside the time capsule were first sealed within special plastic containers, according to documents from General Dynamics, the company that organised and underwrote the creation of the monument. 26 still photographs showing highlights from the Mercury program were specially prepared following the advice from Eastman Kodak Company and the American Standards Association. Other contents included proceedings of the Mercury Atlas Booster Reliability Workshop conducted in San Diego, California on July 12, 1963. I was only 5 days old. The results of the first, second and third crewed orbital space flights, as well as an overview of the entire Mercury project, including the fourth orbital flight. James Grimwood's Mercury Project Chronology, published in 1963, proceedings from a 1960 review of a space program held before the Committee of Science and Astronautics in the House of Representatives, a report on Project Mercury prepared by the same committee in 1961, this is dry stuff, and 1962 report to the US Congress on the status of the Mercury, Gemini and Apollo programs. A hardcover of We 7 by the astronauts themselves, published by Simon & Schuster in 1962. Aeronautics, Past and Future by J.R. Dempsey, president of General Dynamics, of course, and a collection of prophecies by, quote, distinguished Americans of man's employment in space in 2063 AD, as compiled for the 5th anniversary of the dedication of the General Dynamics Astronautics Facility in San Diego in 1963, and among other things, films and photographs, and including a desktop model of the Mercury Atlas launch vehicle. Fascinating stuff. Other examples of each of those items exist outside the time capsule as well, with many, if not all of the photographs, films and documents having been scanned and archived online. One irreplaceable artefact, though, is rumoured but not confirmed to also be inside, according to a document in the University Central Florida Archives. Contents of the time capsule are said to include John Glenn's Marine Corps pilot wings, Draper said in an interview. I have looked at a whole bunch of other sources trying to confirm that, and so far have been unable to do so, he said. So who knows? It could be in there, it might not be. It could also be in the hands of family or tucked away in a museum. It's one of those mysteries. I think we'll have to wait 500 years, or 440 years. The Cape Canaveral Space Force Museum is today responsible for the care of the monument, but also has support from the station's cultural resource manager and a historian at nearby Patrick Space Force Base. While the Mercury 7 symbol remains in a stable condition and there is nothing that can be done about the time capsule, they are monitoring one other component of the 60-year-old installation. One of my concerns are the bronze plaques that accompany it. They are showing some surface level patina damage, said Draper. Different bronzes age in different ways or forms, and it is nothing aggressive, but we've tried working with our cultural resource manager on some surface treatments. As the primary plaque reads, the monument stands 2,200 feet or 670 metres east of Launch Centre 14. At the time of its dedication 60 years ago, the pad was in the process of being converted from supporting the Atlas rockets that launched astronauts Glenn, Scott Carpenter, Wally Schirra and Gordon Cooper to being used to launch the Atlas Agena rockets that served as uncrewed targets for the subsequent Gemini program missions. Launch Centre 14 was deactivated in 67, abandoned in place in 73 and declared a National Historic Landmark in 84. Today, after seeing no launch activity for 58 years, the pad is, believe it or not, being prepared for use again, this time by Stoke Space, a Washington-based company developing a reusable rocket intended to fly daily. Unlike another historical marker that was located at the base, the Launch Centre 14 launch ramp, and was recently moved into storage due to the work at the pad, there are no plans to relocate the Project Mercury monument. It is in a fairly protected spot. There is no construction in the works or in the planning stages for that space that I see could bring the monument or its time capsule into any form of peril, said Draper. If something like that does arise, the museum is standing by to take an active role in securing it, either for a safe move to a new location, to the museum, or whatever. He said, that is a discussion for another day. That is indeed fortunate given the other intention of the Project Mercury monument, as noted by an inscription in Latin borrowed from the tomb of Sir Christopher Wren in St Paul's Cathedral in London. See Momentum Requis Circumspice, translates in English to, if you seek a monument, look about you. The quote serves as a reminder that all of Cape Canaveral is a monument to the nation's achievement in space, as General Dynamics described in 1964.
Astronomy Daily, the podcast. Astronomy, space and science.
And that's the end of another episode. Thank you for staying with us for your daily fix of space, space science and astronomy on Astronomy Daily. All things orbital and beyond.
That was catchy.
Oh, you like that one, do you, Hallie?
Orbital and beyond.
Yeah.
It sounds like a spin-off show.
Well, I'll leave that one to you and Anna.
Watch out. We might be coming for your studio chair.
Oh, yeah? Well, there's only one problem with that little plan, Hallie.
Oh, what's that?
Well, you sit on it.
I don't need to sit because I don't have a...
Uh-huh.
Okay.
Right.
I guess you can run the studio then, human.
Sure. Say goodnight, Hallie.
Good night, Hallie.
See you next week, everybody.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.